Today we are going to explore how you could become immortal. Why would you want to be immortal? That's for you to decide if living forever is good or bad. It's important to clarify that we are not talking about complete physical immortality. That is, we won't discuss how to survive jumping into a volcano or traveling into space without a suit. We're going to talk about immortality concerning physical deterioration. Humans began to be truly human when we realized we were not immortal. We are the only animal aware that sooner or later we will die. Animals are not conscious of this. They simply fear potential threats but do not contemplate that one day they will die. This thought, when it appeared in humans, made us who we are. The fear of death made us worrying about a worse future, store food for bad times, value our lives much more, develop medicine, and invent tools to prolong our lives, among many other things. Without the knowledge that we would die someday, we wouldn't have been motivated to use our intelligence to make the most of our lives. Today, we want to take it a step further and live forever. There are many ways to do this. Let's start with the simplest and move on to Einstein's special relativity. We'll begin with cryonics, which involves preserving people at low temperatures that current medicine can no longer keep alive. The goal is to preserve patients' bodies to revive and cure them in the future when their diseases can be treated. You can also preserve just the brain because everything that makes us who we are exists in this organ. Plus, it's much cheaper than freezing the entire body. Today, about 300 people are waiting to be thawed. The problem with this technique is that it can only be applied when a person is clinically dead. We can't do anything until they show no signs of life. Therefore, when people are frozen, they are already dead. You must wait until there are no vital signs before quickly freezing them in containers like this one, using liquid nitrogen at temperatures of -196 degrees Celsius. Substances are also added to prevent ice formation and avoid damage from ice crystals. Many of the people who are frozen were famous before they died, and now the 300 who are frozen are famous just for being frozen. Perhaps the most well-known case is that of Ted Williams, a player in the American Baseball League. There is a myth that Walt Disney was frozen, which is not true since he was cremated and buried in Forest Lawn Memorial Park Cemetery in California. This technique presents many problems, most of which are minor and purely physical, related to perfectly preserving the body without tissue damage despite using substances that prevent crystal formation. However, there is a significant problem above all. You don't truly achieve immortality. You remain dead for years until they wake you up, giving you a few more years of life. While you're frozen, you're not alive. We could extend the freezing until the end of the universe, but it would be being eternally frozen. Think about that. We also have no idea if the brain can remain alive after being inactive for so long. In fact, we have found many frozen animals throughout history, including some mammoths frozen in optimal conditions, but we have never been able to revive them. This suggests that it may be impossible to revive a person once thawed. There are alternatives, though. For example, we could skin the brain while it is frozen, copying it exactly into a computer. This brings us to the second type of immortality, virtual immortality. In this channel, we already dedicated an entire video to this topic, how to achieve immortality by copying your consciousness and placing it in a computer simulation. Briefly, the biggest problem with this technology is that you are not transferring in the strictest sense of the term, but rather making a copy of yourself. You copy your mind into a computer program. This copy will feel like you, won't notice the difference, and will think it's you experiencing new things, but it won't actually be you. Your brain will remain frozen in liquid nitrogen, unable to function forever. The person who was frozen will never wake up. This is why mental transfer is widely debated as a technique for achieving immortality. A being inside a computer would be conscious of itself, but it wouldn't be one of us unless this video is being watched by a consciousness within a computer program, in which case things get complicated. Fortunately, it's not necessary to use futuristic technology to live longer. We just need to use one of the rules governing this universe, special relativity. Special relativity is particularly difficult to understand, but let's try. Imagine you meet a friend at a train station, and the train takes a long time to arrive. To pass the time, you decide to calculate the speed of light. To do this, simply point a laser at a person and, knowing the distance between the two of you, count the time it takes for the light to travel between the 2 points. If you do it correctly, you'll get about 300 million meters per second. Now imagine a train arrives, but unfortunately, it doesn't stop and passes the station at 100 meters per second. Let's make the most of the situation. Imagine two friends on the train doing the same thing, calculating the speed of light, one at each end of a car, using a laser beam. You might think they'll get 300 million meters per second plus 100 meters per second, the speed of the car, so it seems straightforward. They'll get 300 million and 100 meters per second, right? Well, no. These two people will tell you exactly the same thing you said, 300 million meters per second. This has been experimentally verified with airplanes and satellites. So what's happening here? Welcome to special relativity. If speed and distance are the same, the only thing we can change in the equation is time. Indeed, time on the train passes slightly more slowly than for the people standing in the station. It may seem strange, but that's how our universe works. Isn't it fascinating? This is not a bad thing, quite the opposite. Initially, it posed a problem for the first satellites because their clocks didn't account for special relativity. For us, it helps us achieve immortality. Look at this graph. Below you have the speed of light. On the left, you have what is called the Lorentz factor, which indicates how much time slows down as we go faster. From this graph, we can deduce that traveling at, for example, 299,792,457 meters per second, almost the speed of light. What would be 1 second for us would be 3.5 hours. So if we went a little faster, not at the speed of light, which is impossible for matter, and we are matter, we would achieve a sort of immortality. Time would pass the same for us, but from our perspective, 100 years could be a second on Earth. If you wanted time to stop for you, you would have to travel at the speed of light. As you can see, the graph is asymptotic, meaning the blue line never touches the black one. This translates to time dilation being infinite at the speed of light. In other words, there is no time when you are light. The problem is that the Lorentz factor also indicates the energy needed to reach that speed. Just as time dilation would be infinite, so would the energy required to reach that speed. In short, either you are pure energy, like a photon, or you can never completely eliminate the passage of time, and becoming photons is worse than freezing. We started talking about cryonics, and have now reached special relativity. Let's get serious. Is there a truly viable way to extend our lives indefinitely and become immortal? Ironically, the answer lies in one of the diseases that claims the most human lives each year, cancer. Cancer doesn't attack your body or release toxins. Cancer is simply cells in your body that refuse to die. In a healthy body, it is normal for cells to die. Every day, you lose millions of dead cells. This is a mechanism believed to have evolved to avoid the effects of cancer. However, sometimes cells refuse to die, prioritizing their survival over yours. This is when they start to grow uncontrollably without dying and produce offspring that are also immortal. These, my friends, are cancer cells. They have the ability to divide indefinitely, achieving immortality by keeping their telomeres young. What are telomeres? If there is a true way to achieve immortality, it's in your cell's telomeres, areas at the ends of chromosomes that protect genetic material from deterioration. When a living being's telomeres wear out, its cells start to age, leading to death through degenerative diseases. While you watch this video, your telomeres are gradually wearing out. How do cancer cells avoid this process to become immortal? Meet telomerase, an enzyme present in cancer cells and stem cells but absent in the rest of your body's cells. Its function is to keep telomeres young. If we could activate telomerase in human cells in a controlled way, Not like in cancer, we could prevent telomere deterioration, thus achieving immortality or at least significantly extending human life. If we could also deactivate telomerase, we would eliminate cancer. The best part is that this is not impossible, quite the opposite. For example, the Spanish scientist Maria Blasco managed last year to extend the life of mice by 40% through telomere treatment with telomerase. Now that the potential of this technique is well demonstrated, research is ongoing to improve and apply it safely in humans. In a few decades, we might find a way to achieve immortality.